Hi folks, Tim Gauntt here, Director of Product Support for Hartzell Engine Technologies. I'm currently sharing contact information, so if you have any questions regarding this presentation, please feel free to shoot me an email. I want to thank each of you for participating, and a special thanks to Concord Battery and Chris Holder for sponsoring this seminar. And with all that being said, away we go. We're going to talk about electrical systems today. Basically, it's a fundamental electrical system program. This is something that we have had, this is the majority of the questions that we get of people that call in. So I think it's always good to go back and hit the fundamentals, talk about electrical, and see where we end up. I do have to put this screen up here. This presentation is only a reference. It's only educational material, not to be used for a primary source for maintenance, service, or overhaul. I have this up here because I got a call from the FAA, I don't know, it's been months ago now, and what they told me was that they had found my name in a logbook. And that logbook entry had stated that the gentleman that they were, I guess, looking at the logbooks, they said that they had accomplished an STC and that they used me, meaning my name, as the approved data to install that STC. Well, you know, I know some of you out there are probably laughing because we know you can't do that. I'm not approved data. I'm not acceptable data. I'm just a reference. So anyway, just so you all know, that's where we stand. Hartzell Engine Technologies, just a little history. We were founded in 2010 when Tailwinds Technologies purchased the assets of Kelly Aerospace. As you can see, we've picked up several different product lines since then. Most current being in 2020 with aerospace welding and quality aircraft accessories here in Tulsa, Oklahoma. Kind of just a screen that shows the different product lines that we now have between the family of general aviation, Hartzell general aviation companies, you know, Hartzell Prop, Hartzell Engine, and AWI. We're based in Montgomery, Alabama. That's actually wintertime you're looking at right there, which is just quite lovely. We do have aftermarket and OE support. We do have manuals. Not all of our manuals are published because not all the manuals are actually available because of proprietary OE products. Could be because they're just a one-off product that we built for somebody, but if they are available, they will be through ATP, Aircraft Technical Publishers, and they are electronic, and they are by subscription. Let's talk about starters a little bit. As you can see on the screen, there's various types of starters. I mean, we have some engines especially on the Lycoming side. Well, actually, Lycoming and Continental, that we may have 2 or 3 different starter applications for a particular engine. A lot of it comes down to what are you looking for as a customer. My main goal is to make sure that you get a product that works for your operation and the way you use the airplane. Not necessarily because it's the lightest weight starter or it's the latest model or whatever. I just like to get you what'll work best, what I feel will work best for you. Historically, there you go. Who needs a stinking starter? I mean, give me a break. Just climb out there and give that thing a whirl. Isn't that how we did it? I mean, some of us out there, including me, are probably just a little bit on the older side, and we had no problem, you know, hand propping some of the airplanes because the airplanes that were being hand propped were actually made to be hand propped. Not something I would recommend. Safety-wise, it's not the best way to go, so it's not something that we condone, but you know darn well that it happens every day. Charles Kettering, he was a founder of Delco. Everybody's heard the name Delco. They've been around forever. They had a lot of electrical components. They were big in the aviation industry. And he actually, and his group, Delco and his group, they actually are the ones that patented the engine starting device. It was in 1915. And there's a story that goes along with that, you know, the general manager for Cadillac, his wife was trying to go someplace, car stopped, she couldn't get started. A buddy of the managers came out, cranked the engine got the thing going, but it kicked back, broke his jaw, and later he died. So the manager for General Motors or for Cadillac said, look, I want an electric starter. So he went to Charles Kettering, he set a group up, that became Delco. Starter motor is just opposing magnetic fields. I mean, think about it. You're running current through a coil, and you're running current through a coil, right? One's the armature, one's the field coil. If you take 2 magnets and try to put the 2 north sides together, it will not work. They're going to kick off from each other, and that's exactly what you get with a starter. The more current, The more wire, the heavier the wire, the stronger your magnetic field, the stronger starter motor you'll actually have. In general, all we're doing is converting electrical power to rotary mechanical motion. We do it a couple of ways now. The later model starters are all what they call permanent magnet starters, and the older style, and some of the newer ones, are wound field coil. Always keep in mind, permanent magnet starters are very voltage critical, because you've only got, with that magnet in there, you have a set opposition. That magnet is opposition, you have a set opposition. So if you drop below certain voltages, typically about 11 volts on a 12-volt system, or 22 volts on a 24-volt system, the starter will not work. Wound field coils, on the other hand, are not as sensitive. So if you start running voltage into it, even if your battery's almost dead, that same voltage is going to the armature side and going to the field coil side, and that thing will start to turn. Think about the old days. You'd hit the starter and it would just, it would just try to turn. You will never get that on a permanent magnet because it won't move at all. So that's why some people actually prefer the wound field coil starters. Motors, all different parts to a starter itself, but basically you have to have a way to transmit that torque from the starter to the engine. The old starters, mechanical Bendix drives, they've had their problems over the years. I mean, some people like them, some people hate them. Everything now that's newer is electromagnetic solenoid, and all that does is engage the pinion gear into and out of the ring gear itself on the engine. High inrush current. This is what it takes. This is the amount of current that it actually takes to get the starter, the engine actually turning. That initial inrush of current, what's it take to take that thing from rest? Your cranking current is the normal cranking when it's actually been started, and it's trying to go. Typically, high inrush current's about 190 amps, and the cranking current is 80 to 95 amps, something like that. If you put an ammeter on the starter cable and you're pulling 400 amps, there's something wrong. There's something wrong with the starter, probably shorted, and it's just sucking everything dry. Weak starter, won't turn the engine too good. It cranks real slowly. Remember, resistance. Resistance creates voltage drop. All of these older airplanes that you and I are dealing with every day, they all have grounding and resistance issues just due to their age, the age of the wiring, the age of the terminal connectors, just in general, they do have resistance in the system. So we always got to make sure that we check that resistance, because that drops the voltage. If it drops the voltage and you have the permanent magnet starter, like we just talked about, it may not even try to start. So we got to get that part down first. So keep that thought in mind. We get a lot of calls that people want to know what starter they should use, and the first thing we're going to ask them is, how many teeth you have on the ring gear. You get damage on it, or you're just trying to buy a new starter. There are only two ring gear assemblies out there, on the support assemblies, and they either have 122 teeth or they have 149 teeth. The 122 teeth, 122 tooth, however you say that, starters, we're on the older Lycoming engines, all the 720s, all the 0235s, and the older 320s, and I think a couple of the old 360s. Everything current is 149. It's simple enough. I mean, you can see what it says. They're identified by squared off values, blah, 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 all that kind of stuff. My opinion, count the teeth. You only got to be able to count to 122. If you get to 123, you got 149 tooth ring gear, and you can pick your starter based on that number of teeth and the voltage needed. Engine kickbacks. Kickbacks are just notorious on these engines. The problem with an engine kickback is that it would literally fracture, it will literally break the drive gears, it will also break the starter. I mean, if you have a kickback damage and it hits that starter, when that starter is trying to turn that engine over and it turns backwards, it can literally break the starter right off the engine. I had an instance where a gentleman called me, he said the starter's going woo, 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 and it wasn't actually starting the engine. So we went through all the normal troubleshooting. Finally said, you have to take the starter off, we'll see what we got from there. He called me back a little bit later and said, by the way, I know what's wrong with it. The starter's laying in the bottom of the cowling. It literally had separated kickback and separated the starter from the engine itself and was just laying down there. All he was hearing was the starter turning with nothing else going on. So it's like, that will actually do it. If you have an engine kickback, 33 milliseconds will break a starter, and you might see something like that. And then you have an actual broken starter. This one just managed to break the front housing. You can see it just broke the housing right off the thing, and obviously it would be grinding away, making all kinds of racket. And it's an engine kickback that does this. We have some starters that are warranted against kickback. This is one of them. It's got a shear pin. It's the NL series. It has a shear pin on the inside. You can fix that in the field, but once it's gotten so bad that's broken this way, obviously the starter's going to have to be replaced. This starter would be covered under warranty because it is warranted against engine kickback. Battery health. Now, when you're troubleshooting a starting system, an electrical system in general, doesn't make any difference. Look at your battery health, and you can see the thing I've got red down there is a cap check. I know you're going to be hearing from Chris sometime during this seminar series, and he's going to talk about batteries and cap checks and things like that, so I'm going to leave that to the expert, Mr. Chris Holder. Troubleshooting some more, voltage drop. We talked about voltage drop a little bit. You should never have more than a half a volt drop in any system, except maybe as it passes through the voltage regulator. The voltage regulator is a consumer, so it may take some voltage to keep it actually running and doing what it's supposed to do. But if you're checking and you've got 11 volts at a solenoid at the battery, and you've got 11 volts at the solenoid, and you've got 5 volts coming out of the solenoid, you got something wrong inside that solenoid, because you should never have more than half a volt drop. Grounds, if you're checking a ground or bonding from any surface to another, no more than 0.2 ohms. These are all reference marks in that maximum resistance should be 0. I mean, you shouldn't have any resistance at all. But the fact that you're using a meter that may or may not be calibrated, such as that, if you want to check the ground between the engine and the airframe, just stick the engine in a nice bare spot, stick the firewall, and read what you've got. If you've got more than 0.2 ohms, or as a gentleman told me, he says, I've only got 2.5 ohms, you've got a problem with grounding, and nothing on the electrical system is going to work correctly. ICA or recommended maintenance. This is something that always comes up. We get a lot of questions on this, and I always like to make sure that people understand that the starters are all different. We have legacy starters like the old Prestolite style, things like that. They're all covered in the OE2 electrical manual. We'll tell you what the actual recommended maintenance is. That's in the overhaul manual you would have to buy, but if you need information like this, shoot me an email, I'm going to send it to you. If you have the SkyTech, the HET starters like the E-Drive, something like that, there is no recommended maintenance. You've got 2,000 hour TBO, and you hit that TBO, you're done. The legacy SkyTech starters, kind of like the NL we just saw in that picture, there's no maintenance required on those, and you've got a 2,700 hour TBO. After that point in time, it's a throwaway starter. OE proprietary starters, per the OE recommendations. This is something that happens that people don't always understand, but when we build a product for an OE manufacturer and they want it to be their product, they are then responsible for any type of ICA, recommended maintenance, anything else that goes on with that unit. So people call me and they want to know, like just say a 149-12HT-H that we build for Robinson helicopters. They want to know what the ICA is for it. They need to go back to Robinson because that's proprietary to them. Obviously, for prolonging life, torquing fasteners, using backup wrenches, blah, 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 do not exceed duty cycle. This is one of the biggest things we run into is we get these starters. Somebody told me, a starter quit. They call me up, your starter failed. And they make them fill out the warranty form. They send it in. When that starter hits the dock and the box comes off the truck, I can smell the starter up in the office. That is probably going to be a burned up starter. You know that smell, that burned up electrical smell. And odds are they've exceeded the duty cycle. To give you an example, on a SkyTech starter, basically you don't crank it any more than 10 seconds. You allow it 20 seconds to cool down. You can do that 6 times, and then you have to let it cool down for 30 minutes. Are you kidding me? 10 seconds. Count 10 seconds. If I just was quiet for 10 seconds during this presentation, you all would get very uncomfortable because 10 seconds is a long time. It's like the 30-second thing before you get oil pressure. You better have oil pressure before 30 seconds. It's the same thing with the starter. The engine's probably already started running. But you get hot starts, fuel vaporization, hot days on the ramp, just got fuel, and you've got to crank this thing through to get all that vapor out of the system and get fresh raw fuel into the cylinder. That's when you got to be careful about exceeding duty cycle. The other one, flight training airplanes. These kids are learning to fly, and of course, they just kind of beat things up a bit, as I'm sure some of you know. Okay, enough of start. Let's go on to alternator systems. You can see again, we have a variety of different alternators, different models, different makes, different applications. Some are standard, some are OE, some are upgrades, just a variety of different things you can use. Think of an alternator theory as AC, because anything that rotates, and rotates a magnetic field inside a wire, is going to induce a current flow into that wire, and that is going to be AC, because you're going to get an AC because you're using a magnet inside. So that rotor assembly is nothing more than an AC output device, north and south, and as you spin it, you end up crossing those lines of that stator assembly, which induces in and provides an AC voltage, single phase, okay? Now, think of the AC generators, magnetos. Of course they have an AC output. If they didn't have an AC output, why would we have to rotate the plugs the way we do? Don't we take the plugs out, we rotate them top and bottom for cleanliness, put the dirty ones on top, let them burn off, let them clean off a little bit, but we also rotate them one forward in the firing order of the engine, because one magnet one system would be firing negative and one system would be firing positive on that AC sine wave. So we move them forward in that firing order so that they get the benefits of both, and that wears your plugs much more evenly. Tach generators, the majority of those are AC output. Generators, it rotates, so it does have an AC output. They just use a commutator to change it into DC for the aircraft system. Alternators, always AC output, but they are rectified to DC for the aircraft system. This is the guy that did it. This Glenn Ferrison guy worked for Chrysler way back when, good gosh, it's only 1960. Way back when, 1960, and what he did is he is the one that patented the alternator rectifier unit, used the diodes to convert that alternating current to direct current, so the AC to the DC. This started in 1960. He is the one that developed three-phase, think of it, three-phase, 3 north poles, 3 south poles on that rotor assembly. That was three-phase rectification. And this is what you're going to see. If we take a three-phase alternator, right, and they're going to have phases, as it rotates through, you're going to have a phase every 120 degrees, okay? So it's pretty even. If you look across the top of that thing, this thing wouldn't work at all. You've got as much negative as you do positive voltage. The systems, the aircraft systems, wouldn't have a clue what to do from that point. So you'll hear about half-wave rectification. Half-wave rectification takes that bottom part of the sine wave and literally just chops it off. So now you only have the top part, which is DC, but look at how lumpy that DC is. That wouldn't run a system. Could you imagine this trying to run a radio in today's world? That radio would go absolutely nuts. So what we have to do is we try to close it up a little bit. And we go to full wave. Now what we've done is we've taken that bottom half of the sine wave and laid it up on top. So now you notice the bumps. Notice those bumps are getting closer, okay? As those bumps get closer, now the DC output starts to smooth out, and the equipment, the radio equipment and such, responds much better to that. Now, most of the alternators we build, in fact, all the alternators we build except one, are three-phase alternators. So you'd have something like this. We have one alternator, the ALTF-LX, which actually is a 6-phase alternator. So just from this picture, you could take that and add in 3 additional phases. So where you see the blue, add 3 more, red 3 more, green 3 more in that same time period, in that same period of time, that 360 degrees, okay? Which means your in itself is getting much smoother on its own. Now, increase the frequency, turn the thing faster, sucks all this stuff into the left, and as it does that, that becomes smooth on top. And sometimes you may have to throw a capacitor or something like that to take that last part off, but in a lot of cases, on that 6-phase alternator that we have, you don't need any other type of device on top to cut that extra wave you got up there, so it works out fine. Generators and alternators. I'm an older guy, and to me, there's still a lot of generators out there. I got no problem with generators. We went through a phase in the industry where everybody wanted to dump all the generators, go to alternators because it was the cool thing to do. Generators are fine. Generators, if they support what you are trying to accomplish, you go to breakfast and you go every month and you fly to your favorite little airport, 50 miles away and have breakfast, and you got a generator on the airplane, it does what it's supposed to do, leave it alone. There's no reason to just automatically change to an alternator. However, if you have a generator that you have to get replaced, you can't get it. You get parts and they have to be automotive. You start getting into those type of situations if you put a new panel in. You put a new panel in, the radios aren't going to like the generator as much as they would an alternator because it's not a nice smooth flow. There you go. Now change over and get an alternator, generator to alternator replacement kit. The problem with generators is the low terminal RPM because they were so big and bulky. When you spun those things, you couldn't spin them very fast on the high end because there was so much bulk that you had to rotate. Alternators, you know what they look like. They're nice and small and compact. Generators are big and long, and that was a big armature to be whipping around through there. So when you see airplanes, right, you pull the power back on an airplane, all the lights go dim. Right? That's a generator. You don't get that with alternators because they are able to maintain a higher output at low engine RPM because they can be turned at a higher terminal RPM. Different alternator products. There's the original Ford products. A lot of people don't know that the original rights, the IP, the intellectual property, as we call it, is still owned by Cessna Aircraft. I question sometimes if they understand they still own it because we will send somebody to them to get a manual, they'll send them right back to us. We don't own it. We can't print the manual for it. There is a specific manual to overhaul and repair the DOFF series alternators. Chrysler, same thing. Chrysler, the IP rights for that is owned by Piper Aircraft. The last approved manual on those was in some of the old PA-23 service manuals, and the latest one of that does have a section for overhauling the alternator. That's the same thing we use when we overhaul the alternator because it's the most current data available. Prestolite, we own Prestolite, various part numbers, ALU, ALX, ALV. We also have our own product line that replaces a lot of the Ford, Chryslers, and Prestolite series. We own a Jasco's, if any of you out there are using Jasco, and of course we own Plain Power, which is just makes alternators replaces almost anything out there now. Ford style, typical, you've seen these before, just your terminals and that type of thing, that's what they look like. Chrysler, this is old Chrysler style, this is what's called a square back. Take that rectifier assembly on the top left corner there, if you take that off and make it round all the way, it's called a round back. Latest models are the square backs, and of course we have a replacement for those if you want to get rid of that. This is a Prestolite style. Notice if you can see almost just lower than the center of the picture itself, you see a little bitty thing in there. It says F1 and F2. Those are the field terminals. I have a lot of people tell me they are not marked. Yeah, they are. They're marked right there on the brush block assembly. It doesn't matter. As long as you have one being powered and one being grounded, you're good to go. The alternator is going to work. The alternator does not know which way it's turning, and it does not care. This is one of the later model ES alternators that we build. This would be on a Cirrus. It would be Alt 2 on the Cirrus. This is one of the Jascos. This is what they all look like. They're very identifiable with that big blue cover on them. And this is Plain Power. There's a variety of different Plain Power ones, but this is a good picture. It just shows kind of the idea of the Plain Power itself. I use this one because it shows, look at the relationship between the pulley and the body of the alternator itself. It's a small alternator, still has the same output that some of the older Fords and Prestolite does, and it's probably, 2/3 the size. This is an interesting one because this is one of those things that these alternators are almost, well, they are. Internally and all that, they are absolutely identical. But notice the differences. You've got two field terminals on the ALV 9610, one field terminal on the ES 124. Notice the snout. The ALV 9610 has that black snout on the bottom. The ES 124 does not. They are PMA'd against OE units, but they are not interchangeable. As an example, that snout that's on that 9610 sticks down below that lower cowling, that lower baffle sticks down below there because the only way these cool is by differential pressure. So if you don't have that snout sticking down below that piece of baffling, the temperatures are the same, you're going to burn this thing up in a heartbeat. So you have to be careful. The 9610 replaces like the old Crittenden's, the old 9510s. The ES 124 is strictly a replacement for the 656802, which is the new alternator they use on like the Moonies, the Cirruses, things like that. Okay, so we're troubleshooting. Pilot complains, we have that all the time. We're used to it. basically, you gotta know what's wrong. You know, they tell you they have low output. Well, low output of what? Do they have no voltage? Do they have no amperage? What won't the alternator do? What won't the system support? Remember, voltage is controlled by the input to the field of the alternator and the RPM of the alternator. So you have field voltage going in and the alternator is turning, and amperage is controlled by demand from the bus. This is not a system like a generator. This is an alternator system, and the demand from the bus, when you turn things on that bus, that is the load that the alternator supports at a preset voltage based on the voltage input and the RPM on the alternator, okay? As long as you don't turn more on than the alternator can actually output, you're going to be within the rules themselves. Think about it. I think the FAA requires, or they recommend 80%. You never exceed 80% of the output of an alternator to be on the bus itself. So if you've got a 60 amp alternator, I think that gives you like 48 amps you could have, would be your demand on the bus maximum. That's what they would recommend. These are just some numbers to look at. Basically, if you're checking your field resistance, if you want to know if the field itself is correct, 3 to 8 ohms on a 12 volt alternator, 8 to 12 on a 24 volt alternator, give or take. The main thing is it smooth when you rotate that alternator through, or is it just jumping all over the place, indicating you have a bad spot on the slip ring, or you got a brush that's bouncing there, or something like that. Don't get hung up on the numbers. They're just a reference thing, once again. 0.5 volt drops in the system. We've hit that before, which is why we hit it again, just because of that. And you can full field it. If you actually take the disconnect the regulator from the field of the alternator, and you connect a jumper from the output of the alternator, which would be connected directly to the bus through whatever size, say a 60 amp circuit breaker, you now are what's called full fielding the alternator. Do not have any equipment on. You can fire this thing up and you can watch the voltage go up and down. It will follow the throttle because there's no control, meaning there's no voltage regulator in the system itself, okay? All that tells you is it'll produce. Does not tell you it'll carry a load. Aux terminals are always used for either between 2 alternator systems on a twin engine or between a dual alternator system on a single engine aircraft. And basically what it's telling you is, did you actually lose one alternator and you're actually only run on one instead of 2? Remember, in all cases, when you have a dual alternator system, it will be set up so that the second alternator will take over from the first one, or the first for the second one, whatever, and you'll never see it. You got to have some way to see that indication, because if you don't have a way to do that, you could be flying around in a twin and you lost that alternator on the right-hand side 2 weeks ago, and you won't know it until you lose the left one. So we always have some way in there to tell people that, hey, you have lost one of the alternators. Alternator noise, there again, 0.2 ohms of resistance between. That's 99% of what we find. There's a resistance problem in the system. But be careful about toys. This is something that has come up in I don't say recent years, but probably the last 5 or 10 years. People are now putting different types of components in the airplane, such as laptops, hooking up iPhones, just all kinds of games for the kids when they're going and flying and things like that. None of these devices have been tested to see how they will affect any communication equipment that's in the airplane itself. We used to have this little thing called cigarette lighters in there. For some of you that are older like me, you remember them. They were cigarette lighters. And of course, they came out with service information to get rid of those cigarette lighters, because they were basically a direct short. Remember, you plug the cigarette lighter in, you pull it out, you got this glowing red short, and then you light your cigarette from that. Well, they found out there was no protection in the circuit. So they said, here, either put this new circuit in or pull it out. Most people just pulled the pulled the cigarette lighters out because they didn't want people smoking in the airplane anyway. So it worked out well. Well, guess what's getting put back in the airplanes now? They are putting cigarette lighters in, or cigarette lighters back in, but they auxiliary power ports. So they've renamed them, okay? They do have protection, but people are plugging stuff in and you don't know what they're plugging in. So always be aware of that. Maximum 1 volt AC, you should never have more than 1 volt AC coming from an alternator, because that would tell you that one of the diodes one or more of the diodes has failed, and you're actually putting the bottom half, along with the top half, the bottom half of that sine wave into the system. Remember, energized alternator field creates electromagnet. So there we go. So if I am creating an electromagnet, I can turn on the battery, turn on the alternator, turn on the field, energize the alternator field, take something like a hacksaw blade, lay it on top of the alternator, and I will feel if I have a magnetic tug. If I have no magnetic tug, go backwards. Find out why you're not getting any power to the field. Okay? If I do have a magnetic tug and you rotate that alternator and you got no output, you got a bad alternator. It's just that simple. Very quick way you can check it. It's not guaranteed, but it is a pretty good way you can check something real quickly. Manuals, we talked about manuals before. Gear drive alternators. This is one of the big problems with gear drive alternators right now. FAA has been looking at it pretty closely. All this information from the Continental for the per mold engines is in the M-0 standards practice manual, maintenance manual. It did supersede SB 11.3, 95-3B, etc. Gives you all the information you need for gear drive alternators. Troubleshooting review, basically here you go. The same thing we talked about before, ohms of resistance, maximum voltage drop, 0.2 ohms resistance in any system, and a maximum 1 volt AC. That'll get you going and keep you at least heading down the right way. Another part, don't operate alternators without with the battery offline. I don't know why I get a lot of people that call me up and they say, well, they turned the alternator, they turned the battery off, or they're actually building a system that they can start on the battery, take it off the system, and use the electrical to power the system. It's not going to work. The battery acts as a ballast. It's like a ballast there to accept to smooth out and accept what the alternator is putting out over and above what it would use. It'd be like trying to run a turbocharger system without a controller. It's just going to sit there and go back and forth, up and down. It'll never know what it's doing. Helps prevent the voltage spikes and overvoltage systems, the overvoltage systems from tripping. If you don't have an alternator, and you lose your battery all the way down, what if you got a tachometer? What if your tachometer is being powered by the electrical system that the alternator is not working, you run the battery down so low? Do you care? Maybe not on an airplane, but what about on a helicopter? What if you were actually using a dual tack where you have to keep your needles married together and you lose one of those? How do you do that? Troubleshooting. For more troubleshooting, we do offer troubleshooting flow charts for both starters and alternators. They're on their respective websites for planepower.aero, skytech.aero. Go to support, and there's just a ton of information there that you can use for troubleshooting whatever system you're dealing with. PMA and STCs. This is one of the things that a lot of people get themselves kind of in a bit of trouble on because they don't understand the difference between them. We have products that we build that are for the OEs. I think I've said that before. We PMA products against some of those OE products. We have TSO products like the heaters and things like that. And then we have STC kits. And bottom line is you've got to do your homework before you do the installation to make sure that PMA and or STC is eligible for the aircraft. And it does not affect any other STC installations that are already there. And that's kind of you got to do your homework to check this kind of stuff out. Remember, application guides are just what they say. They are guides. They are not approved data. So just because the application guide says, oh yeah, this will fit my Cessna, blah, 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 and you go to put it on and it doesn't fit, what's an application guide? Maybe you changed the engine in that Cessna. Maybe you went from a 470 to a 550, and now you've got a different, a different installation. So anyway, you got to think about all that when you're making alterations to installation instructions. You can do that. You have the authority on an STC, but the change has to be minor. You can't make a major change on a PMA or an STC without going back to the manufacturer. So when is that change major or minor? If it's not minor, then you've got to submit. You've got to sit there and you've got to do a 337, do a field approval, do something to make that approval actually real for your particular installation. AC 4313, been around for 100 years. I mean, good gosh, when I went to AMC school back in, let's just say, when I went to AM school back in the day, this was the Bible. This is what you used to do the majority of the work. They didn't have the manuals to the extent that they have them now. So this was considered acceptable data. You would use this data. You could do a lot of work through this through using, AC 4313. It is still good material. It still tells you what size wiring you should be using for a particular application. wire size for the amperage loads, for the length you're running, all that type of thing. Tells you what fuses, circuit breakers, all that. It's all in here. This is where I send the majority of our home builders. They come to me and they say, what size wire should I use for the starter? How do I know? I don't have any idea what airplane you're actually building. Where's the battery going to be? Where's the starter going to be? How far is the battery from the starter or the starter contactor, that type? You need to make those measurements and then make that determination. I can tell you what the starter's going to draw. We said that, 190 amps max, say 90 amps continuous. So I can tell you that part, but you got to make the determination on the wire size itself. I can't do that for you, and I really don't want to do that for you because I'm not there at the system itself. Proper grounding. Is this proper grounding? I don't know. I look at that thing and I think it's obviously old, right? Been there for a long time, but there's some things that make me suspect that maybe it's been there a little too long and make me wonder how good a ground this actually is. Look at that big cable. It's got all that old style insulation where they use the cloth type of insulation. It's actually coming all apart there. You can see it. Notice the other terminals, if you can visualize, those wires are coming up the case or across the top there, and that terminal end is bent 90 degrees. It has to be to make it fit where it is. So how long has this thing actually been here? You know, it kind of makes me wonder. They look pretty old to me. It looks like they've been there for a long time. But then there's another issue. Why so many? Why do we have, I'm counting 4 grounds on that thing. What are those 4 grounds for? I'm going to say the big one. I'll just venture a guess. I'll say that big one is your main ground from the engine itself back to the airframe. They've got a nice big ground on that, as it should be. That's great. Is that a good ground? We'd have to make that determination. But what are those other ones? What are they for? And I will bet you that what's happened is somewhere along the line, somebody has added a new thing to the airplane itself, and it said install a ground. So they did. Then maybe they decided to put on a, let's say, a CHT, EGT, graph thing or something like that. And it said, create a ground. So they did. And before you know it, you've got 4 different grounds, and who knows what they actually go to. And that can cause a problem in itself. It's called a ground loop. And what happens is it's almost, I'm not going to say it's the same as an electrical system, but it's basically, it doesn't know where to go. It can't find the ground because it keeps making a loop. And it keeps looping until it finally does find the ground, but unfortunately, there's resistance in every one of those wires, and it creates an actual resistance problem in the airplane itself. Okay, so be careful of things like that. Gear coupling interface. For those of you that get the joy of working on the per-mold engines and the alternators themselves, be careful. This is a big deal with the FAA right now because there have been some incidents that have been attributed to improper installation of this gear coupling. And I'm going to tell you something. I think this is the whole world has done us an injustice as mechanics on this. Notice you have that face gear. That's what I'm holding in my hand there. That face gear is built by Continental Engines. The alternator you see all the way to the left is built by us. The gear coupling that you see that's got the orange elastomer in it, this is the newer style gear coupling, the elastomer type, that's built by 2 or 3 other people. So here's one part in the engine where you've got all these different components coming together. What about manufacturing tolerances? What about if I have plus, plus, plus? How far can I push that gear coupler with the orange elastomer forward into the face gear that I'm holding? If I push it too far forward, I'm going to be into that elastomer. I'm going to grind off that elastomer, and guess what's going to happen? It's going in the oil. Once it goes in the oil, small pieces could be sucked up into the system, block an oil passage, and before you know it, you've blocked the oil passage to something that's critical in the engine itself. So you got to watch this, and what I recommend is this one actually looks pretty good. If you look the way the gear track is tracking there, looks like it's pretty good, but what I would do is whenever we do this, put a gear coupling on, you always put the alternator on the engine, put some Prussian blue, the blue dye on that gear tooth, one tooth, put it on the engine, fold it down, rotate the prop through, pull it back off, and see where your actual gear is tracking. It is the only way you will know for sure, and that's what you need to know for sure what happened and how that gear coupling is tracking with that face gear. Because if not, you may end up with something like this. This is not good. This alternator coupling has come apart. Either the coupling is bad, the shaft is bad, it was jammed up. Think about it. If I push that gear coupling too far up into that face gear, I'm going to force that alternator shaft, that rotor shaft, to bend. If I rotate it and bend it at the same time, ultimately it's going to break. When it breaks in the front part of that engine, for any of you that deal with the permols, you know that's just going to cause a mess. This one really bad. It came right out through the side, up to the opposite side of the engine case. So you know you got major damage inside this engine. And these are the pieces. Notice what I have highlighted. The circle on the shaft up there. Look at that Woodruff key slot. That slot is worn out, which tells me that that alternator has been operating loose. That gear coupling has been loose on that shaft, which means the gear coupling's been slamming back and forth. Every power surge, boom, 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 it's been hitting that shaft. Ultimately, it's in there, it just literally broke the shaft itself. Notice the arrow, it's pushing to that thrust washer. Per Continental and per Hartzell Engine Technologies, you will always change that thrust washer. You cannot tell me that once you put a copper washer, it's copper faced on one side, once you put that copper faced washer and you bolt that down and you take that back off, that you can tell me that you can put it in exactly the same spot as it was. Throw it away and put a new one on. I truly believe that is the majority of the problems we have. People reuse that thrust washer, and when they bolt everything back down, sure, they get a torque, everything works fine, right up until the time the engine starts, the alternator runs with a load, heats, cools, everything loosens up because that thrust washer all of a sudden is no longer contacting the way you thought it was. And now you get a loose coupling, and it just goes downhill from there. This is the bulletin. This is the SAIB Special Airworthiness Information Bulletin the FAA published. They published it back in June 20 of 18, so this is like a current document because it just came out in the last few years. So this is something, and basically what it talked about was an airplane that crashed, and this airplane that crashed sucked up a lot of the orange elastomer that we saw, that gear coupling, got up in the oil system. Oil system was blocked, seized the engine, the guy crashed and died. And that never works out well for anybody. So this is something that the FAA is really keeping an eye on, and in particular case on this SAIB, they are relating these problems to installation by us. And that's scary because in most cases, I think we do a phenomenal job of keeping these airplanes flying. I think we maybe have just slipped a little bit on these. I'll tell you, one of the things that I can say, reason I can say that is because we sell a ton of these alternators to Continental, okay? And we sell a ton of these alternators to the aftermarket. The ones that we send to Continental, the hundreds and hundreds, I don't know, maybe we're at 1,000 now, I don't know. Of all the alternators that we send to Continental, I have never had, I can't say never, I have had one gear coupling alternator failure on any of those factory installations. On the field, not so much, hasn't been so good. And I can only attribute it to installation practices and or old parts being used that shouldn't be reused, such as that thrust washer that I was just talking about a few minutes ago. So I think it's something we need to focus on, to the point that I actually have a presentation that we do for the IE seminars that is based on nothing but gear coupling installation. Did it with GNN aircraft engines. He's run into trouble with Dennis, has run into trouble with before, and it's just one of those things that we have come up, and we actually wrote a presentation just for this subject. Corroded terminals, are they corroded? I don't know. I guess they are the way you look at it. It looks like they've been there for 100 years too. See that piece that's right in the center of the page, that capacitor that goes between F1 and F2? You can't see the other side, but it kind of curls around there and goes between the two. I told people you don't need to put this back on. Because we don't require it on our alternator. We don't require that kind of filter. However, because it is part of, and one of you all is one that turned me on to this, because it is listed in the aircraft electrical maintenance manual, and because that part is available, you will need to reinstall that if you're putting that on. So just kind of keep that kind of stuff in mind. That even though we're the unit manufacturer, you still have to abide by what the OE aircraft manufacturer recommends. This is a good one. I always like this one because this is one that they took a brush block assembly out. This will be a press flight style brush block assembly, and I think you can probably see there's like a carriage bolt, and that little carriage bolt goes through a slot, a specific size slot in that brush block assembly. Well, it looks to me like somebody has loosened up. Notice on the top there's two nuts. There's one on the top, which is where you would put your field terminal, and then there's one below that which is how it fastens to the brush block assembly. Looks to me like when somebody was taking this thing apart, they loosened that top one and inadvertently loosened that bottom nut also. So now they pulled that thing off, that little stud assembly dropped down, and when they tightened that bottom nut back, you know, against the block assembly, it didn't get in the slot. That the carriage head portion did not get in the slot in the brush block. And guess what? Now you have the shunt. See the shunt there that goes down, the white wire that goes down to the actual brush itself. Now it doesn't have a good connection and it's loose. And that looseness is going to cause an intermittent system. Okay? So got to be careful about that. Here's one that I don't know how they managed to do this, but somehow somebody managed to put a brush block assembly back in a press slide alternator. And when they did that, instead of just pushing the brushes down inside the brush block, and then you take a little piece of steel pin or something like that, and you run it down through, there's a hole down through there, you run it down in there, that holds your brushes in place, you install the brush block assembly, you pull the pin out, snap, they go against the slip ring, and you're good to go. Somebody looks to me like somebody tried to use their fingers and take this thing and shove it all down in there, and they got, looks like one of the brushes got put in correctly, but the other one got kicked out there, and it was running sideways on the slip ring. And it actually worked. This thing actually had time on it, and it worked for a while, right up until time it got directed to the shunt. You can see where the wire comes up through the center of that top brush. When the wire came up through that top brush, guess what? It shorted, the whole thing goes offline. Okay? So watch that. There is a correct way to do this. Here's another good one. This is one, we don't use this kind of a nut. This is what I always refer to as, it's an MS nut, I always call them turbine nut. Because I always used them, you know, they seem to be holding turbine assemblies and things like that together. We don't have any nuts like that. But somehow this alternator went out, and you can see, that's your stator assembly that you're looking at, those copper wires, and you can see that right above the nut itself, where it's all white there, it's actually burned through. Those stator wires are coated. They're like varnish coated, and this thing actually was inside there, shorted across there, burned up the wire because the alternator went offline. That's one whole phase, so it probably just took out the whole phase, took out the whole thing. When we take it off, we find this. Well, where'd that come from? You know, how did it get in there? So it looks to me like something was getting worked on. It got dropped down inside there. You know, you drop something, it's going to go in the worst possible spot it could possibly go. This was an interesting one. If you can see this, I hope you can. Right at the bottom, say at the bottom terminal, you see a little plus underneath that terminal, okay? That plus is telling me that's your positive output to this alternator. I will tell you that above the middle diode that you can see there's right in the middle of the page, the next terminal that's up, that's all burned up, that's the ground terminal. In this particular case, this guy was running this alternator, it's a per mode alternator, you can see the snout there on the bottom. He was running this gear drive per mode alternator, and the cable was connected to the positive, and it was tie wrapped to the negative, to the ground. Well, you know what tie wraps do. They vibrate, that type of thing, and my goodness, this thing just burned itself up. Smoke, everything. This guy was very excited. Not in a good way. Here's an alternator that looks like the alternator nut itself was loose. Now, how did that happen? I don't know. I would never say it couldn't happen here, but in most cases, we've got a pretty good system to prevent that. Usually something like this happens because somebody's doing their belt tensioning and they turn the nut in the loosening direction to see how much torque or how much torque they have on that assembly for that belt. So, you know, be careful, always in the tightening direction. You know, you got three methods. You got the torque type, you have the belt deflection, and you have the vibration type that actually measures the vibrations. Video updates, we have a lot of updates online. Feel free to go on them and find them. They're on the various, product line websites. Just go to those, you'll find them under there. You know, a lot of good stuff in there to visualize. And with that, that concludes this electrical presentation. Hey, I really appreciate your time. I look forward to any questions and comments you might have. Thank you, good luck, and God bless in 2022. Bye-bye.